Continuing on with our multi-part series on chemical conflicts, this is episode 122 of the Rule Your Pool podcast. I'm your host, Eric Knight, and with me, as becoming more regularly, Terry Arco. Thank you for being back on the show.
Hey, thanks, Eric. Glad to be here.
Yep, I'm glad to have you, and this is really not my area of expertise. You were on the last episode, but as we both know, due to some technical difficulties, I had to re-record it, unfortunately, but we got you now. I think you can really add a lot of value because I don't know as much about these conflicts as you do. So in this episode, Terry and I are going to be talking about algicides. Algicides are always, if they're not named chlorine, a contributor to chlorine demand. Terry, is that your experience as well?
Absolutely. Any type of chemical you use that puts something which chlorine has an affinity to oxidize is going to create more chlorine demand.
Right. We have a few more episodes after this with you, so let's get right to it. Episode 122. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. I had a call from a customer, I think it was last week, shortly after the last episode came out. And he called me and said, hey man, I can't hold chlorine for a week. And you made mention in your episode that chlorine will conflict with things in the water. So in this episode, what I want to break down is the multiple different things that chlorine is going to conflict with, because all of these things are going to contribute to the chlorine demand. Rapid fire, Terry, I want to go through the different types of active ingredients that you might find in an algicide. And let's just talk about what happens when you put that in water. Sound good?
Yeah.
Okay, copper. Copper sulfate is the most common ingredient I've seen. What happens when that goes in the water?
Commonly what's used is copper sulfite pentahydrate. Right off the bat, that's going to create some chlorine demand. And copper, when you have copper present in the water, that's one of the first things that chlorine is going to want to go after. Any form of metal, when you add chlorine to the water, the first thing it's going to want to oxidize is those metals that are in the water.
Lowest energy, highest affinity for those metals.
And the thing about certain products like that, these copper algicides and so forth, is that they're in a chelated form. So initially, I would say there's not going to be an interference there. But what happens is, over a period of time, from excessive oxidation, which is going to be happening all the time, every time you're adding chlorine, and contact with the water, which is hydrolysis, those chelators begin to break down. And over a period of time, that chelator is going to release copper, which is basically going to just be in the free form of copper, which is what chlorine is going to want to go after and oxidize. So if you're using copper algicides, the thing to keep in mind with that is, initially you may not have a problem, but as you continually use those products and they build up over time, the chelation that you've had in the pool for a while is going to get oxidized away. It's going to hydrolysize, and it's going to release that copper into a free form, which, based on where your pH goes, can lead to a staining issue, which chlorine is going to want to oxidize at that point as well.
Do you know if the chelating agent in those copper algicides is EDTA?
Yes.
Okay, that's why it can break down.
Right, exactly. It will break down over time.
Well, we've seen it for sure. SC1000 is not EDTA, so that's why I ask.
Well, I worked formerly for a company that sold a copper-based algicide, and it was an EDTA chelated form of copper, and it was a low percentage. So we didn't see a lot of issues, but I can tell you that there were issues that would come up, especially with people who used it consistently.
It's an effective product. I think all of these things are effective at what they claim to do, especially if they have EPA registration. And by the way, if you're using a product that does not have an EPA registration and they're claiming to kill algae, don't use that product, because that's a violation of federal law. You have to get EPA certified to be able to make those sorts of claims on bottles. The point is, it's not that the chemicals that we're mentioning in this episode don't work. No, they do work. They wouldn't sell if they didn't work.
That's correct.
It's that they leave behind byproducts that conflict with chlorine, and that's what we're talking about. If we go back to Orenda's philosophy, it's proactive pool care with no chemical conflicts and no long-term byproducts left behind. Algicides violate the last two of those three. Well, actually, all three, really. They're not really proactive. Some could be, but generally speaking, you're going to add an algicide when you have an algae problem. Some people will put in the next type of algicide as a preventative. the 30-day, the 60-day, the 90-day algicide. What are the active ingredients in those kind of products, Terry?
Well, so those would be either a quaternary ammonias or they would be a polyquaternary ammonia.
What's the difference between those two?
When you add a quaternary ammonia to water that's got chlorine in it, the first thing you're going to do is you're going to create ammonium ions. Those ammonium ions are going to convert to monochloramines very quickly. And those monochloramines are going to convert to dichloramine very quickly. And that's the killing process there to the algae, is that those chloramines are slower. They tend to penetrate more into the algae, and that's what causes the algae to die off. However, you're also consuming a lot of chlorine in doing that. Then the dichloramines basically, those should hopefully leave the pool in the form of a gas, but that doesn't always happen. You can get a buildup of chloramines.
That would be trichloramine or nitrogen trichloride. That's
right.
The air quality issue on indoor pools. So when you're saying chloramines, I'm thinking, man, combined chlorine is such a huge problem for commercial pools especially. And for the listeners out there, if you ever test a difference between your total chlorine and your free chlorine, that difference is called combined chlorine, and that's chloramines. Ideally, that number is 0. You don't want that because chlorine is combining with nitrogen compounds. And if you have that, again, we've talked about this in previous episodes and blogs, the only question you need to be asking is, where did the nitrogen come from? In this case, it came from the algicide because Quat, Q-U-A-T, is short for quaternary ammonia. Now, polyquat has polymers in it as well. Is that correct?
Yes.
Okay, so elaborate on that.
Polyquat basically is taking a quaternary ammonia and they're attaching a polyacrylamide to that chain, if you will. So it's termed as a polyquat. The main reason for the polymer is that polymers, as we know, basically, and we'll talk about this in our polymer episode, but just real briefly, it creates a long chain. A lot of carbon atoms on that chain. Those carbon atoms are very strongly charged, and they tend to go towards negative charged material, and they form flocks and that sort of thing. So they bind things to them very quickly and very easily. In the sense of the algicide, the polyquat algicide, the polymer is going to stick more to the algae. And especially if you have free-floating algae, it's going to grab that algae, or it's going to form a flock of that algae to the quaternary ammonia to kind of, I guess, get a better killing agent from that sense. And also any dead algae that's floating around or whatever, the idea is the polymer is going to flock that, and that's going to go to the filter and be removed better by the filter. That's kind of the idea there.
Interesting. And I know that this allows it to have more staying power because that's the 30, the 60, the 90-day
Correct.
Algicide products are typically polyquat. Now, not only will chlorine conflict with both the poly and the quaternary ammonia, chlorine will attack both of those things, and that increases your chlorine demand, some more than others, but generally speaking, it's going to increase chlorine demand. That's not the only product that conflicts with this. Our enzymes do too. We have seen people add polyquat. Well, I should say I haven't personally seen it. I've seen a video shortly after somebody poured the product in, and he texted me and said, "Why is this foaming like crazy?" And he put polyquat algicide in a CV600 pool. He put it in an Orenda pool. And there was no algae in the pool. It was done to be preventative going into the fall, and it bubble bathed like crazy. Why did that happen?
Well, there could be various reasons. I would suspect the number one reason, if you use a quaternary ammonia, and I believe on many labels it even says quaternary ammonia will cause foaming. And a polyquat, so basically you've got the polymer, which is a hydrocarbon form or a petroleum-based polyacrylamide attached to the quaternary. And what do enzymes do? Enzymes digest oil. So the enzymes, I'm sure, go after the oil in that polymer. And in a sense, what happens is it becomes depolymerized. And so now you've got quaternary ammonia, straight quaternary ammonia in there, which is going to foam. I would suspect there's probably other reactions that are going on, possibly with surfactants that may be in either one of those, and that can cause foaming as well.
Yeah, that's our theory. Enzymes bubble when you first put them in anyway. I just figured it was going after something organic, and that's when we figured out polyquat is not compatible with CV600 or CV700 or CE clarifier. It's not compatible with our enzymes. So if you are having an Orenda pool, please don't put a polyquat algicide in there. You shouldn't need it in the first place, but it's going to foam. All right, moving on. Sodium bromide. I don't want to dwell on this because you and I did a very detailed episode on bromine in the past one. I think I can take this on a little bit and then just fill in the gaps. Sodium bromide is a salt of bromine. Table salt is sodium chloride, but this is sodium bromide. And the reason this consumes chlorine so much is because chlorine has an affinity for oxidizing it into hypobromous acid, which is the killing form of bromine, which cannot be stabilized to protect it against sunlight degradation. So it could be an effective oxidizer, it could be an effective algicide in the short term, but it's going to get burned out very quickly by direct sunlight. Therefore, it's this vicious cycle, never-ending cycle, by the way, of chlorine attacking that bromide ion and recharging the bromine cycle. Did I miss anything in that?
I know we covered this, but just to consider that even in bromine tablets that are used for spas or hot tubs, you've got BCDMH, those tablets. That's bromochlorodimethyl hydantoin. So why is the chlorine in there? Well, the chlorine is in there to act as an oxidizer because it oxidizes the sodium bromide into active hypobromous acid, which is the killing agent. And by the way, there's lots of research and lots of data where they claim that hypobromous acid is a better algae killer than just regular hypochlorous acid, that it kills better. I'm just saying there's papers out there. I'm not saying whether they're correct or not. I'm just saying there's data that makes those statements. And I think based on the data that makes those statements, that's what launched these chemical lines to where they're saying bromine's a better way to kill algae than chlorine. So here's these sodium bromide based products now.
Do you buy that?
I don't buy it. I don't
either.
I think chlorine used correctly is the best algicide anybody can have.
I agree. Bob Lowry said that. Chlorine is the best algicide, or free chlorine, I should say. It doesn't matter what type of chlorine you put in the pool. HOCl is what he was referring to. I agree with that.
And we could spend the whole episode on that and about proper free chlorine and how proper free chlorine can do a lot and go towards a lot.
Dang, Terry, you're making me write down all these episode ideas. I have customers and listeners that suggest episodes too, and you keep coming up with some good ideas, so maybe we will do that. Let's keep moving in the interest of time, though.
The thing with the bromine is that, exactly as you said, so they've come out with these sodium bromide-based algicides and products you put in there. The problem, though, as we stressed in that episode, which everyone should listen to on bromine, is that hypobromous acid is going to eventually, once it's done what it needs to do, it's going to convert back to that sodium bromide salt. That sodium bromide salt is never going to leave the pool unless you drain or get an incredible amount of splash out, something like that. So it's always there. Every time you add chlorine to that pool, the first thing the chlorine is going to want to do, it's going to have the affinity to go after that sodium bromide, oxidize that sodium bromide. Well, now that consumes your chlorine that you're putting in the pool to deal with bacteria and sanitize and so forth. So that's the issue there. You've got to really be careful on using those types of products.
We're talking about things that chlorine really likes to oxidize. Now, it's very hard for chlorine to get rid of something like sunscreen or makeup or deodorant, but it's very easy for it to get rid of a metal. It's very easy for it to oxidize because the energy required to oxidize iron or copper is much lower than it is for a complex hydrocarbon like sunscreen. Am I understanding that correct?
Absolutely.
That same thing applies to sodium bromide because the bromide ion is very easy for chlorine to attack, and that's why it has an affinity for it. So continuing on with things that chlorine likes to attack, let's talk about the other metals that we have. So we talked about copper sulfate or copper sulfate pentahydrate. Now let's talk about mineral systems. These are supplemental products that can be put in skimmer baskets or strainer baskets. They're quite popular and they are effective against algae. These are things like silver chloride, coppers, or even ionized copper, which is more of a residential system that you might find at a retail store. It's a specialty system that supposedly you don't need chlorine, and they just electrify copper and they put copper into the water. What do these conflict with, Terry?
Well, again, chlorine demand. The idea of this whole thing with the silvers and the zincs and the different things that are being added through these ionizers comes from different industries, not necessarily from the pool industry. But when someone's going to say, hey, this is all you need, first in a pool, I'm going to say, you're never going to get away from needing chlorine, no matter what you're using. So if you have ionizer systems.
Or a residual sanitizer, yeah.
Right, you still have to have residual sanitizer. If you buy into something where you get an ionizer system and they're telling you zero chlorine or you don't need chlorine anymore, you should run from that because that's incorrect and that's going to lead to a lot of problems. But chlorine demand, the same thing applies. I think in the short term, initially, when these products are added, they have a benefit. However, the issue becomes when you have these, say, the copper or the silver, or whatever it is, that begins to build up in the pool, and chlorine's going to oxidize those. Hydrolysis is going to do its job, and you're going to have these spent metal ions now that are going to build up in the pool, and that's where chlorine is really going to get consumed, because chlorine's going to just go after those like boom right away. That's the same thing as if you have copper in your source water or iron or any type of metal, manganese or whatever, and you're filling your pool. Again, the first thing that's going to happen when you add chlorine is it's going to get consumed oxidizing those source metals. And it'll do the same thing when you have an ionizer in there.
And eventually it passes a threshold, the pH gets high enough, you get a stain. So those are metal issues. We are not a company that dwells on metal issues, although we do get a lot of calls about stains. That's not really our wheelhouse, maybe in the future, but for right now, that's really not our specialty, but we do get a lot of questions. So let's wrap the algicides group with ammonia-based algicides. Now, we talked about quaternary ammonia, and I would lump that in with ammonia-based, but there's two others that if you look at the active ingredients, I have seen ammonium sulfate and dimethyl ammonium chloride. I think it's pretty safe to say chlorine is going to combine with these because it is nitrogen. Is that correct?
Yeah, and that's actually the manufacturers, they would say that that's how the product is supposed to work in a sense. Okay, so ammonium salts, for example, which that's a dry powder material. So you're pouring a certain amount of an ammonium salt into a pool that's mucked up with algae, looks like a lake. And then you're going to add chlorine, liquid chlorine. It might be 1 or 2 gallons. If you're doing cal hypo, it would be 1 to 2 pounds. And the concept there is you're oxidizing that ammonium immediately. So you're creating that ammonium from the ammonia salts. However, you'll notice in those products, they tell you not to just add the chlorine once right after you add the product, but then by the next day or so, you've got to come back and do a superchlorinate again. Why? Well, that superchlorinate is to hopefully deal with or break up the chloramines that you've created to do the kill in the first place. And that's a huge consumption of chlorine right there. And that's where you can get problems down the line. Again, I'm going to say in the short term, these products tend to work. I worked for a company, we sold ammonium salts, and they were effective and they worked. But I will say one of the things we dealt with in many cases was people who had gone through this system and done this system, and then they're having a hard time getting back to where they can create a chlorine residual after the use of these. And a lot of that just has to do with what's been left behind and that it's consuming.
Right, combined chlorine, chloramines, all that stuff.
Right.
We know, again, I come from the commercial pool world as a swimmer who got really sick from breathing this stuff in when it off gases. So for me, when I see combined chlorine, that's a red flag immediately. And inorganic ammonia creates monochloramine, dichloramine, and trichloramine. But dimethyl ammonium chloride is actually organic ammonia, and that is a lot more complex. It takes more chlorine to get this stuff oxidized. It takes more for it to get out, so it's just going to increase the chlorine demand even more. However, it is a very popular cleaning agent. It is commonly used on decks to clean floors and bathrooms, and it's used in your house. If you have cleaning products, I won't say brands, but very popular cleaning products, look at the active ingredient. It's probably either sodium hypochlorite, chlorine, or dimethyl ammonium chloride or dimethyl benzyl ammonium chloride or something like that.
Dimethyl benzyl ammonium chloride, which is a really common ingredient in a lot of like Lysol and those kinds of things have it. And I'll also say if you use any kind of a purge, this might be more so for spas, but there are pool purge products out there as well.
So that leads us to the last thing that chlorine might conflict with, at least on this list, I'm sure there are other things, is polymers. You know, we mentioned it in the previous episode, which of course I couldn't use your audio, so I guess we need to restate it. Chlorine will also conflict with polymers in the water. So polymeric clarifiers was one example that you gave, which I didn't know. I actually learned that, and I'd like to touch on that because if you have a polymer clarifier, is that the same kind of polymer that you're going to have in polyquat, algicide?
Yes, it's the same. If it is a synthetic clarifier or polymer, and what I mean by synthetic, it means that the polymer is a polyacrylamide polyglycol, something like that. Many of them use those, or they just use what's known as polyacrylamides. That means they were synthetically created. They weren't natural polymers like chitosan, and also they're petroleum-based. Of course, chlorine's going to go after all those things.
And so are enzymes.
And enzymes as well.
Right on. Okay, well, I think that's it for this episode. So when we talk about algicides on this show and in our blog, it's not that we're anti-algicide because they don't work. I'm going to restate it. We don't like algicides because they leave behind long-term byproducts that conflict. They conflict with chlorine, and they're not even as effective at killing algae as HOCl, hypochlorous acid, good old chlorine. Free chlorine is the best algicide you can have, and that was not just us saying that. It seems to be pretty well understood. I was looking at some medical journals, and I found out our white blood cells create hypochlorous acid when they're trying to kill germs. And maybe it was you that gave me that hint and I started looking at it. You're nodding, but we're not on camera. So HOCl is the most known, most trusted disinfectant in the world. Is that a safe statement to make?
That is a very safe statement, yeah.
Okay, so if you want to avoid chemical conflicts, if you want to be proactive, if you want to rule your pool, try to avoid these things. It's very easy to prevent these chemical conflicts. Simply don't put the products in your pool. If you feel that you need them, just understand that there are consequences to doing that, and you're going to have to deal with the baggage. That's all we're saying. Terry, anything else you want to add to this episode?
I think where people get into trouble, even when they do use these products, they're using them as a replacement to good free chlorine in the pool. And when you start off there, you're just going to wind up in trouble.
Right. Fair enough. This has been episode 122 of the Rule Your Pool podcast. Terry, thank you again for being on this episode, and we will see you on the next episode when we talk about alternative sanitizers. Thanks, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.